Alright, hey, real quick, on your piece of paper. Okay, this is something you should already have. You should have the formula for how we find the product of two functions. So if this is my original function where I'm taking g of x and f of x and multiplying these together in no particular order, it doesn't really matter. Okay, you're multiplying these together, right? What we did yesterday is we showed how did they come up with the first derivative for this function where these two things are being multiplied together. Now they could be super big polynomials, but how did they come up with it? So the shortcut that we came up with yesterday was you had to figure out that we're taking the derivative of the first function times the second, and then you're adding that to the derivative of the second times the first. Now, I don't mind if these were switched around, I don't mind if like f of x is in front, as long as you understand what we're doing. We're taking the derivative of the first times the second equation, or function, and then we're taking the derivative of the second function times the first. So one of the examples that we did yesterday was I just made up a polynomial and we went through it. So I'm going to just do a short example of that. This is an example that if you were not here, I would like you to have in front of you right now. Okay, just put the pass back there. All right. So let's say that this is my function. Okay, I'm going to multiply these two things together. So the two functions that I have multiplied together, let's go with 3x minus 2, and let's go with x squared plus 5x. Okay, so I'm just kind of picking two random ones. This is very similar to what we did yesterday. The trick is the shortcut. When you want to take the first derivative, so first derivative is you take the derivative of the first function. So this is where you can do your shortcut. So the derivative of the first function is just 3, because you drop the power up front, you subtract 1, it's just 3. We take that times the second function completely.
2x plus 5.
Not yet, we're not taking the derivative. This is just this part. Just the derivative of the first times the second. Plus, now the derivative of the second, Tyler, what was your derivative you said?
X squared plus 5x.
No, 2x
2x plus 5.
2x plus 5, thank you. And we take that times the first function, which is
3x minus 2.
the 3x minus 2. Alright. Okay. Now, again, if you're not paying attention to that, what we did is we took the derivative of the first. This requires that you know the shortcuts. So if you don't know the shortcut for how I figure out the derivative of that first function, right, this is my f of x, and this part here was the first derivative of it. So if you don't know the shortcuts, this is impossible for you to do.
No, it's not impossible. You could write it all out on the side and do the whole.
Yeah, I wouldn't want to do that.
But you could. But then you have to memorize all the steps for that, though. That would be harder.
Yeah. This is g of x. This is g prime.
Hi, Tyler. This is what time I got.
Hey, I don't like all the talking. Let's go. Now, there is another way to do that problem. I always like to give you outs in case you're that one person like you're on the test day. You're freaking out, you can't figure this out. You can't remember it's the first, the second, you can't remember what you're supposed to be doing. You could FOIL that whole thing out. FOIL it first. And then you could find the derivative of it.
Oh my God,
Okay,
it's so much easier.
after you do that. Now, why I wouldn't choose to do that. So you're thinking, like, on this problem, yeah, it might be easy.
If it's a really big problem.
Yeah, if it was really big. If it was really big. Like let's say I had a power of like 4 on the parentheses. You'd have to FOIL all 4 of those out, which would be like a huge chart, and then you'd have to take it times the first item, because maybe there's powers. I wouldn't want to do that. So if you know how to find the derivatives of these items separately, you can do that really quick. Now we're not going to do the problem with the 4th power yet. Because you're thinking, I can just multiply that and I can do it faster. Yeah, fine. I haven't got to the problems we need to do for the homework yet. Where they put it to a point where you can't actually like just do the shortcut. Like you have to know how to do this product rule. Because of what's gonna be given to you, you can't actually multiply them together. Because it might be a radical and something else.
We actually have to do that for our homework.
Yeah, so it's gonna be we're gonna get there like Monday. Monday we'll talk about like the weird problems that you can't just FOIL together or multiply.
Wait, what are we gonna have to do for our homework?
Eventually,
briefly.
you have to do this stuff, but on problems that you can't actually multiply together. So like one's a radical, one's not, that type of thing.
So how do we multiply them?
So,
That's a line.
That's what we will be learning probably.
You can multiply radicals and non-radicals. It's just a non-radical
It's like 3
Yeah,
times
it's
the
just
square
multiplying
root
it
of
with this.
8.
So,
Then
they're
why
not
can't we
actually
do
multiplied
that?
together. So, alright, okay. Next, let's do the division rule. Okay, I'm gonna leave this on the board. The reason I'm leaving this part on the board is Doug, number one, you need to know the quotient or the product rule. But the quotient rule will use this. So hopefully that makes sense, like how we're doing this. Okay, so let's do the quotient. This is the part you need to put on your little sheet of paper
On the back?
on the back.
Is this
Now,
how
if
we
you
write
have
it?
a little bit of room, you'll be fine. This one does not take as nearly as much paper as the one we did yesterday.
Do we have to like
So-
earn the right to
Yeah,
do
I don't
it?
have a paper.
We just had white paper from the back. You can grab one if you want.
You can go grab one.
There's no back
If
here.
you want.
So I don't
It's,
have to?
but it's right behind that phone case.
No, you can collect some
You
probably.
just
Yeah, I
look
would
behind
probably
the fun
find it.
case.
But if you don't, then how to do it
Oh, I see it
online.
now.
Yeah. Yeah, Charlie just did it right down in the street.
Alright, quotient rule, here we go. Okay, quotient of x. So this is the new name for the quotient, instead of calling m, multiplying, I'm calling it
Wait,
quotient.
wait. What kind of rule is it? Quotient.
Quotient rule.
Okay. That's what I'm using.
Did M stand for multiplying?
Yeah.
Oh, that's cool.
Yeah.
That's
What
what-
is it?
that's-
Oh.
Okay, I was gonna use pivot, man. Alright, I like it. Alright, so quotient, Q. We're gonna try to figure out how to find the first derivative if they're dividing things like this. Now, I'm gonna kind of cheat the process to show you kind of how
I
it
don't
works.
think you can do that.
And this will require that you basically know how to divide, you know how to use a reciprocal, so where you can flip things over when you divide by like fractions over fractions, multiply by reciprocal. But this, I'm trying to figure out how to figure out the first derivative, okay? Like what this thing is equal to. So that's kind of the whole goal. It's a formula that we'll get to, that it just works, but it doesn't look like anything we've done here. So that's why we gotta kind of figure out the process for how they came up with it. Once we have the shortcut, I'll give it to you, we can use that from now on. The shortcut's nice, it's simple, it's straightforward, but it just looks different than what you're expecting, okay? But we needed this original function. So what I did, like, how I learned this, is to figure out how to figure out the first derivative, that I basically cheated and I used this rule to figure it out.
That is cheating.
Okay, so-
Straight up cheating.
So what I did is I changed this problem up here. I changed this problem by multiplying the g of x across. Because it's, it's a fraction, right? You have the answer equals whatever you're dividing. You can take the bottom and multiply it over and make it a product on the other side and it would still be the same answer, right? So I can take g of x, multiply it across on the q of x, and that would equal f of x, right? So if I just multiply, it's using the multiplicative property of equality, so I multiplied it across. This is gonna be my setup, because now this problem, I'm just gonna rearrange the order here, just so it's easy to look at. It's the function of x equals g of x times q of x. So, now why I reverse this is because this is a product rule. So if you can see this is the multiplying thing that we did earlier. This is just multiplying. And you know how to multiply and take the first derivative, because we just did it right here. We did the product rule for when you have functions. So, the first derivative of f. So if I want to find the derivative of f when it's a product rule, going through the rules, you take the derivative of the first item, right? So if I'm finding the derivative of this thing, you take the derivative of the first function times the second, and then you add the derivative of the second function times the first.
Oh,
This is what we just did.
Now, this is using q of x's now, so it's got a slightly different look to it. Okay, does everyone see how that's looking right now? Derivative of the first times the second, derivative of the second times the first, and those are being added together. It's using this rule, but it's just taking the functions I give you as your first and second, first, second, right? So that's what I'm doing here. This is my first, that's my second. So derivative of the first times second, derivative of the second times the first.
But I thought we were trying to find Q.
We're trying to find,
How can
no,
you use that?
so I'm gonna rearrange, so it's gonna like come back all the way and say like, we're trying to figure out what the derivative is, right?
Yeah.
I'm gonna just, all I'm gonna do is just solve for the q thing. So I'm just gonna move everything over and there's your answer, and that's the shortcut.
you have to subtract.
So yeah, so we're gonna have to subtract an item over, we'll have to divide an item over, and then we'll simplify this whole thing down, okay?
So I didn't get
Question.
right. That's
Can't you just divide g of x from f of x and then take the
if you could do that, but the problem is we're gonna be at a point where you won't be able to divide because there'll be a radical on the bottom and like a whole number on the top. So like, you can't actually divide them. Like you won't, like you can't just do long division or synthetic division, right, to actually simplify the polynomials. There'll be weird looking things. That might be sines and cosines that we're eventually gonna have to take derivatives of, so you have to know the shortcut.
So I don't know how to do that.
So, yep, that's what we're gonna be going
Good
on.
thing we're learning it,
Good
Drosky.
thing.
No.
That's why you take a
Okay.
All
Alright.
Both of you too.
So, let's finish this out, because we're almost to what my answer is. We're almost to like what the derivative is. So now, to do this, because remember, like Jaden was asking, well, aren't we supposed to be finding this thing? You're absolutely right. So the whole goal is to figure out what the derivative of q is, right? So what I have to do is I have to solve this thing for the q. Before I do that, I need to get rid of this thing. Because that's the only part in the whole problem that I don't need. Because my final answer, what I'm going to put here, needs to be in terms of f's and g's, right? It can't be the whole q function again. So what I'm going to do is I'm going to substitute this out before I start solving. So this is what I need to do first. So I'm gonna take out that.
And then plug in f of x over g.
There you go.
Wow, that
Perfect.
was
So let's
hard.
take this out and let's plug in f of x over g of x right here, because that is the same thing as what q stood for in the very top line. The very top line of my problem, q of x was f of x over g of x. So this will basically help me eliminate my problem where I have like a bunch of different terms going all over the place, and I need to solve for the first derivative. Now remember, the whole goal is to get that q prime thing by itself. So you're right, we're gonna have to subtract things over, divide things, and we'll simplify it and clean it up so it looks better.
No.
Alright, I'm gonna use this side of the board now, so
So
I
we
can.
subtract first?
Okay, so yeah, so I'm gonna subtract over things first. So the first thing I'm gonna subtract over, so with this prime, or f prime of x, I'm gonna subtract over that first thing after the equal sign. It was the g prime of x times f of x over g of x. So I'm subtracting that across the equal sign first. So that's what I'm trying to do is I'm trying to solve for the q prime. And so on the other side of the equal sign, now that I brought over that g prime f of x thing, I should have the q prime over here, and that's still being multiplied by g of x, right? That's on that far right side over there. That's still by itself. Did that make sense how I subtracted that massive thing over the other side of def? One of the last steps, I have two steps to go here, but one of the last steps I'm gonna have to do, divide the g of x over, because remember, the whole goal is to get q of x by itself. I need to get this so I know what my shortcut is. I need to solve for that. So I'm gonna divide this thing over. Now why I can do that, I'm doing inverse operations. I'm trying to solve for like x basically, right? So if there's something being multiplied on x, you can divide it to the other side to solve for it. So I want to get this thing by itself, so the only way I can do that is divide g of x over. So doing that, this is what I have. X, g of x, and this whole thing,
I don't like when fractions.
yeah, this whole thing is like this. Now, I know, I'm gonna clean this up here in a second. Just so, because this looks just terrible. Okay, because you got fractions or fractions, it looks terrible. So, okay. So, to get this thing to look better and hopefully to make sense, okay, hopefully this will make sense to you, is I want to get, maybe combine the top, because I want to like subtract these together, and then I can get rid of the weird fraction thing. So, to do that, to get these things over here to actually subtract with each other, I basically got to get common denominators, because this thing is actually going to the top, and so there will be a g of x on the bottom of that thing. Over here, there's not even a fraction, it's like over 1, right? And I need to be able to subtract them. So the only way I can get this thing to actually subtract over is I'm going to multiply by a g of x over g of x, because that's technically 1, right? G of x over g of x, that's 1. And so now I can be able to subtract over, and so I can rearrange this in any form that you want. But I'm going to subtract these across, so then what you're going to have here is this weird, crazy, complex fraction, right?
Multiply by the reciprocal and the g of x is cancel out.
They won't cancel,
No, they won't.
they'll actually group up.
No.
Yeah. So, because they're both on the bottoms. So,
Nicole, why would you say that?
The reciprocal, then make it on the top.
Okay, so I'm gonna let's actually subtract the top. I'm just gonna rearrange that a little bit up there. So f prime of x, there's the g of x. That's all over g of x. That's terrible looking. That's being subtracted by g prime of x.
You multiply the f of x,
F
or f prime of x times g of x over g of
all
x.
over g of x.
Just so
Yeah,
that you
this is
have it
all
all over
over
g
g of x. All right, fine. So this is like,
Alright, fine.
so what I'm doing here is I'm just cleaning this up a little bit. Like this looks stupid.
I
So
think
Wait, so why
I'm
can
cleaning
you
this
do
up.
why can you multiply it by g of x?
Because
like
g over x or g of x is 1. So this is like 1 over 1. So if I multiply this
Oh,
on that
you're
one
putting-
fact, so I'm getting common denominator, so I actually subtract. So if I subtract straight across with fractions that have the same denominator, basically this is what it looks like. This is kind of my shortcut. You can just make a big fraction bar, right? Where g of x is on the bottom, like this, right? Where if you subtract straight across, there's just gonna be 1 g of x on the bottom. Because when you subtract like fractions, the denominator stays the same, right? So it'll just become a g of x on the bottom when I actually subtract straight across, because now they have the same denominators. Now, what Nicole was saying earlier was like, we have a fraction over, technically this is a fraction, right? This is actually over 1 on the bottom. So what you do is you do a reciprocal to the top. So you flip that g of x over 1 over, and it'll be multiplied. So I'm gonna rewrite this so it looks a little bit better. So f prime of x times g of x minus g prime of x times f of x. And this is all over g of x. And we're gonna multiply this whole thing, because what I'm doing is instead of dividing by this weird fraction, I'm gonna multiply it by its reciprocal. 1 over g of x. So this is flipping whatever we're dividing by on the bottom, right? Because I was dividing by a g over 1, g of x over 1. So instead of dividing by a fraction, you do multiply by its reciprocal. This, what you're looking at right here, let me put this in a bracket. This bracket was on the top. That was on the top of that fraction. I'm choosing to multiply by whatever we were dividing by. So that's the 1 over g of x, because I had to do reciprocal rule. And so what you're left with, and this is my final answer, and I know this may not look like a shortcut, but trust me it is. My final answer, like your actual shortcut that you get, is that you take the derivative of the first item, like the top item, times the bottom, then you subtract the derivative of the bottom,
That's a multiplication thing.
times the top, and the bottom will be squared. This will be g of x squared, because there's actually 2 of the g of x's down there. Now I'm going to rewrite that a little bit different so you can see that bottom, but that's literally the shortcut. Now it doesn't look like one. Trust me, it is. When you actually see a problem where they're dividing polynomials together, it's actually easier doing this rule where you just do the derivatives and stuff, and you're subtracting on the top, and then you just square the bottom, whatever the bottom is. Now, the way that they could write that differently on the bottom, instead of writing g of x squared, they could write the bottom like this. I've seen this in the book. That's g squared, using x as your variable. It's the same thing. More people, I think, like that notation than this one where they put a square on the g. But that's technically the bottom.
What's your preferred notation?
Personally, I like this one. I think sure I don't have to put brackets or anything like that. I can just put a square on it. But some people like it to look that way. To me, there's too many brackets and things going on. Now, I know that's not easy to look at. I know it. But once you see how to use it, when you do like one simple example of it, you'll be like, okay, this isn't bad. I can do this. This is easy.
Oh, gosh. That's all we're doing today?
Yeah, we're just gonna do a couple examples of this and we're done. Easy. No homework, done.
I appreciate that.
So it's Friday and we've done a lot of stuff this week.
We have.
Oh, yeah.
So-
No, I
Did we
literally-
take a
Big learning week.
A lot of
Yes.
learning.
I can't remember if
I
we
took a
did
class this week. Yes,
Yeah.
I took it.
Okay, all right. So, okay, here we go. Let's say, I'm gonna do an actual example of this so you can see one. Let's say that the top was x squared plus the 5x like I did earlier. And we're gonna divide this thing by 4x plus 3. Okay, I'm just kind of making up things. So instead of going into that whole long division thing where I want to divide these things out and then whatever that answer is, I take the first derivative of it. I just want to figure out what the derivative is using my shortcut. first derivative.
Hey, wait, I have a
Can I
quick
just watch you
question.
do this?
What?
Can I just watch you do this?
I prefer that you have this. You can watch and then you can write it down. I'll let you do
I
that.
have a question though. Why can't you just find the derivative of the top, the derivative of the bottom, and divide those two? Or do you
Because
still
that's not
have-
how it works.
You still have to do
There's
that.
No, because it's a longer process. It's like,
You know what I
like when you
noticed?
multiply. Why don't you just find the derivative of both things and multiply together? It's not how it works. Because the areas don't match up. This is all based on area. That's what it's based on.
Derivative is slope.
That's something different.
Do we have the first? Yeah, I know.
Okay,
That's what we
all right.
teaches.
Hey, let's go through this. So, derivative of the top. So the top, if we find the derivative, because again, how I know this is my f of x up here. This is my g of x. That's how I'm thinking about it for my whole function, right? So what's the derivative of the top?
2x plus 5.
2x plus 5 times the bottom, 4x plus 3. And then we're going to subtract, because again, I'm using my little shortcut, my little formula over there. We're going to subtract the derivative of the bottom times the top.
Is that 4?
Yep.
Yeah.
So that's the derivative of the top, or the bottom times the top. And this is all over the bottom squared. And this, when you simplify this, that's what the first derivative is. It's like, it's almost in simplified version form. It's really easy to go through, okay? That to me is way simpler than trying to do long division, do all those steps for long division, get to the final answer, and hope to God there isn't a fraction like a remainder to that thing. Because if there's a remainder, you still have to do that one again.
Ooh.
And then if there isn't a remainder, then you can go to the final derivative, which would be what you get here. This is actually telling me, just by looking at this, there probably is a denominator to this thing, so I wouldn't want to divide those. It won't divide out evenly. But again, multiplying this all out, that's 8x squared. Now I'm just going to go a couple steps just so you can see the final answer. 8x squared plus 6x plus 20x plus 15. We're going to subtract, I'm going to distribute the 4. That's 4x squared minus 20x. All over, foiling the bottom, because there is two parentheses.
16x squared plus 24x plus 9.
4x plus 9. And
Wow,
then
Nicole, you're really smart.
I would combine like terms and get to my final answer, which is 4x squared,
Oh, you oh.
6x plus 15, all over the 16x squared plus 24x plus 9.
Then if you want to have lots of fun, we can go back and we can factor them out again.
You can factor it out and figure. Now, the reason why I did this, by noticing that I can find the first derivative graph is complex. That thing is tough.
What'd you get?
That's a tough first derivative. Like if I had to draw that function by itself, just drawing it, that's going back to what like Justin was saying earlier. You'd have to factor it apart. You'd have to look at, you know, like where the end behaviors go, if there's any vertical or horizontal asymptotes. Like, that's why these derivatives, like finding the first derivative is important that you know these shortcuts. Because if I had to draw that thing, oh man. And if I have to go to the second derivative, if I go to the second derivative, these things get bigger. Like this is different than what you think it does. When you do the second derivative on fractions, the bottoms get bigger. Because every time you have to square the bottom. So first derivatives things get smaller, second derivatives on fractions get actually bigger and bigger and
Well,
bigger.
technically the number's getting smaller if the bottom's getting bigger.
Yeah, but yeah, you're right. But the idea is that like the functions themselves get more complex. So it's one of those things that you just need to see it. It's actually really difficult. I want you to see the shortcuts today.
It's getting smaller.
That's a lot.
It's just a bigger
Yeah, this is the final answer. That's the first
Why can you
derivative.
not like just cross out the x squared?
No, can't do it.
No.
It's called algebra 2.
Okay.
Or algebra.
All right,
That's what I was saying.
all right, we're done for the day. That's all I got.
No, because that ruins that half.
Or